Thanks everybody for being here, and thanks for that really interesting talk, Gabi. It's an honor to be on this panel with everybody. I'd like to begin this talk by speaking a little bit about the audio analysis engine that is part of Spotify's recommendation system. This is the output that Spotify gives when you can run any track in Spotify's catalog through its sort of machine listening tool, and it rates a given track along these sort of 10 to 20 metrics. So this work that I began, when I sort of had the reaction that I think any career musician would have when confronted with these variables, which is to say, these are sort of, they feel like a gross oversimplification of what the art of music is for anybody who's devoted your life to creating music, right? Metrics like danceability, energy, and especially perhaps valence. So in addition to feeling somewhat oversimplistic, they're also occasionally wrong. Even on the tasks that you would expect a machine listening tool to do very well at, for example, the tonality and the tempo. In this case, the machine rates Genuine's Pony as being an A-flat minor at 142, when if you look at this, my sort of human analysis, the human representation, my own human representation of this music, it's actually in D-flat, some kind of minor, some sort of bluesy minor, and the tempo is half what the machine estimates it at. So all of which to say, there are a lot of easy critiques, sort of familiar critiques that you can make if you're a musicologist interested in taking on this sort of big data approach to understanding music. Valence is too simple. Does music even have emotions? What about music for which these audio features have no meaning? I mean, there are genres for which valence and tempo and tonality are simply not applicable categories. So which brings me to what I've sort of come to think of as the paranoid hypothesis about Spotify. Namely that relying on such reductions as those I just hinted at, Spotify will tend to have a homogenizing effect on musical listening and perhaps even on musical production. So here is Pelle Snickers. He's a Swedish researcher writing about this, sort of, I think giving a nice expression of what I think of as the paranoid hypothesis. Basically that it just gives you, well, the title of the paper, more of the same. It's not a service that has functioned particularly well, at least not as a music recommendation system, and moreover, Spotify has been aware of this and is doing it anyway, which really does sound sort of paranoid. I mean paranoid in the critical, not really the pejorative sense. So Snickers is part of a research team that has written what I think is the best book on this subject. It's called Spotify Teardown, published last year by MIT. This is the only work I know of that interrogates Spotify, not just as a force in the music industry, but as a case of platform capitalism, one that participates in broader trends toward corporate surveillance, financialization, and affect management. A company, in other words, not particularly different from Facebook, to which Spotify has indeed had very close ties since 2012. And here you can see just Pelle Snickers comparing Facebook and Spotify directly, and making the call for what he thinks a critical look at Spotify ought to be. So the natural question then for an investigator interested in substantiating that paranoid hypothesis is, how does Spotify make its recommendations? It's a question that's worth asking, but it's actually rather difficult to answer for several reasons. First of all, what are recommendations? The sheer degree to which Spotify has become a recommendation system rather than simply a listening system, that is, the different number of types of recommendation that are made, from autocomplete and search to Discover Weekly to the radio functions, makes it hard to know what a recommendation even is in the first place. Second, the Spotify system is a black box. That is, it's a closely guarded industry secret protected by non-disclosure agreements that nobody really is willing to talk about. And third, there's the issue of the knowability of algorithms in the first place. That is to say that a recommendation algorithm, whatever it is probably not even the kind of thing that would admit of transparent, straightforward understanding in the first place. It's too complex, too frequently updated, and too internally variegated to be knowable in any simple way. And this is Nick Sieber, who's an anthropologist who's actually done fieldwork in the recommendation space, writing about how playlisting works in his experience. So according to one interlocutor, there's not just one playlisting algorithm, but 5. Depending on how a user interacts with the system, her radio station is assigned to one of the 5 master algorithms, each of which uses a different logic to select music. Nevertheless, it's possible to make educated guesses about how these systems work. And if you're careful, you can draw certain types of conclusions from these educated guesses. So here are 3 strategies that I think I'm pretty confident are at work or will soon to be working at the Spotify system. The first one is the future directions. I think it's not actually implemented yet. So this is taken from a group-authored paper written by Spotify researchers talking about the application of the bandit system of reinforcement learning to exploit, that is, use what you know about a user to give them the right content, explore, give them something that will teach you something about the musical world that they're inhabiting that you can then use later, and then actually explain to the user why you made the recommendation you did. They term this rexplanation. So since we don't have rexplanations in the Spotify universe yet that I've seen, I assume this is sort of to be implemented in the future. But it's also a useful indication of just how much data Spotify is logging already on a daily basis. A second strategy is machine listening. This is what gave us the sort of output that I began this talk with. Things that actually listen to the audio content, machine listen, and then rate it in some way. So these are what are termed content-based recommendation systems in the recommender systems world. So in 2014, Spotify acquired a really important content-based machine intelligence company, a music intelligence company called the Echo Nest, whose approach combines natural language processing of sort of the internet of music in general with audio content-based strategies. And there's a lot to say about the philosophical implications such a strategy presupposes, but I'm not going to get into that in this talk. What I am going to get into is a more pedestrian recommendation strategy known as collaborative filtering, or the subclass of collaborative filtering known as matrix factorization. So that's what the rest of this talk is sort of about. So you can think of matrix factorization, because it doesn't actually deal with audio content, as a sort of more naive strategy for recommending music, because we don't actually need any audio signal to deal with collaborative filtering. Nevertheless, it's considered to be a state-of-the-art strategy in a lot of recommendation applications. And this is just Andy Sloan, who's a recommender systems engineer at Spotify, answering the question, how do we make recommendations with collaborative filtering? This is from 2015, but I think it's fair to assume that collaborative filtering is definitely part of the, excuse me, part of the recommender system at Spotify to this day. So this is a standard slide representing how matrix factorization works. In fact, this is one of Andy Sloan's slides from that big data presentation. So it's odd to be, for me, a musician, composer, to be explaining to you, many of whom I imagine are in fact real data scientists, how matrix factorization works, but let's see how that goes. So the basic idea, I won't get into the actual meat of matrix factorization because it's actually not relevant to what I'm doing today. So the basic, most high-level understanding of matrix factorization is, if I'm a recommender system and I know something about you, and I know that you're similar in some way to some other user, and I know that user liked some track, then I might consider, as a recommender system, recommending you that track. So I measure the similarity between users, I can measure similarity between tracks in some ways, and I can use that information to make future recommendations. So the way that works sort of mathematically is, on the left, there's a large, sparse matrix. That means it correlates users and items with some rating metric, either the number of streams, or in the case of like Netflix, an explicit 4 out of 5 stars rating. So every user, every item has a rating, and we have a large matrix. That matrix is not complete because we don't know what every user's opinion of every item in our catalog is. We only know some of them. And moreover, that matrix is enormous. So matrix factorization does 2 things. It breaks a large matrix, which is unwieldy and difficult to work with, into 2 smaller matrices that can then be recombined to approximate the first matrix, filling out the parts of it that were empty in the first place and making the data much more manageable and easy to work with. So that's the basic strategy of matrix factorization. The logic of matrix factorization here is that in that first big sparse data, that first sparse matrix, there are inevitably going to be statistical correlations, patterns. That's what it means, after all, for it to be likely for you to like things that people who are like you also like. That's the statistical sort of pattern that matrix factorization is designed to capture. Now, in order to capture those statistical correlations, and this is the important part for me, this system depends on something, a statistical technology, really, known as latent factors. That's what these F's are in these two, in the right matrix, and the right smaller matrices. I have to hypothesize latent factors that are not actually observable data. They're just hypothesized statistical entities that enable us to recombine what we do know, or enable us to recombine those smaller matrices to approximate the data that we started with in the large matrix. So they're latent factors. They're not actually observed data, but they're necessary statistical expedients to make the data manageable and to make predictions for user item pairings that we haven't actually logged any data about. So these things, they pose a number of interesting epistemological questions, right? In what sense are those latent factors real? Right? In what sense are we committed to the idea that a latent factor, while unobserved, has some sort of ontological weight such that we can predicate a recommendation upon it? Now, to answer this question, it's simple to look back at the history of latent factor theory. And it's interesting to note that it comes from psychology and psychometrics. And it's not that old. It's from the 20th century. Charles Spearman, a psychologist born in, I think, 1863, is the first. He developed the statistical methods and he implemented them in the same year in two seminal papers. One that is, well, there are the names of the papers. One is the proof of measurement of association between two things, that's just statistics. And the second is a paper where he gave a barrage of tests to a bunch of school children and used factor analysis to postulate the existence of a general factor of human intelligence, which he termed G. So G theory and its derivations still have a lot of currency today in popular and academic circles. In a sense, G is exactly what you're trying to capture with a general IQ test. Now, whether G is a good theory, G theory is good or bad, it's clear that for Charles Spearman, the factor is truly a contributing force, not merely a statistical expedient. That is, he's rather explicit on what the ontology of this latent factor is. I'll just read his statement about the ontology right here. Our true correlation in no way deserves the reproach of being a theoretical abstraction, for it only represents the limit to which the observed correlation itself will continually approach, right? In other words, he's committed to a certain realness of this latent factor. Factor analysis was also applied in the 20th century to study personality, notably in the work of Louis Leon Thurstone. His choice to use 5 factors to characterize human personality eventually gave us, toward the end of the 20th century, the so-called Big 5 personality traits that are popular in corporate organizational strategy and marketing and popular psychology. So the Big 5, in turn, have become a basic part of how advertisers, corporate structures, and political operations comprehend and control us. This slide is taken from the late Cambridge Analytica, the political consulting company that influenced Brexit and the 2016 US elections, explaining that they use the science of personality, as derived from the work of Thurstone, to maximize the power of whatever campaign they're involved with. And here you've probably all seen these: openness, conscientiousness, extroversion, agreeableness, neuroticism. These are originally factors, latent factors that were not observed in the personality test, but were rather inferred from them in similar fashion to the matrix factorization I was discussing earlier. So there's a sinister side to latent factor theory in psychometrics and personality theory. To return to the paranoid hypothesis, we might ask whether we would say the same for its cousin in music recommendation. In other words, is Spotify a sort of musical Cambridge Analytica, as indifferent to epistemology and as crassly mercenary? By way of answer, I'll list a handful of things that I think Spotify seems to presuppose. First of all, Spotify presupposes that the ground truth data in that first big matrix is reliable, that there's no algorithmic confounding effect. That would be that the matrix, that first sparse matrix, is already prejudiced by a billion recommendations that the Spotify user has been subjected to in and outside of the Spotify universe. Second, in subjecting aesthetic experience to the same predictive logic that derives from intelligence tests and market research, Spotify assumes that there's nothing special about aesthetic experience, that as a consumer of music, you're in some sense no different from a consumer of toilet paper or a voter waiting to be swayed. Third, that it's okay to make predictions without being epistemologically specific about the latent factors that undergird them. In psychology, thinkers are careful about what kind of ontology they're committed to. This is just evidence that psychologists tend to be careful, or at least that there's a conversation about this epistemology in psychology and psychometrics. This is from Brian Hood, a philosopher of science. He distinguishes between what he says minimal epistemic realism in psychometrics, which is it's possible to justify hypotheses that posit unobservable entities, and ontological realism, where you're actually committed to these things actually being in some sense real. And he says prediction performance, if that's all you're interested in, you don't require believing that they're real. However, if you're estimating ability, you depend on both of these, right? Minimal epistemic and ontological realism. Where's Spotify on this? Which one are they committed to? They never tell us, of course, and they don't care, and why would they? Fourth, Spotify presupposes that there is indeed such a thing as a good recommendation. That good measures of success exist, and that root mean square errors and user retention are good proxies for a quality of recommendation. So this last point, the fourth one, is probably the most instructive. It seems safe to say that Spotify in the end will care about one thing only, the same thing any corporation cares about. We should probably then regard Spotify's professed altruism the same way we regard Google's mission to organize the world's information, or Facebook's to bring the world closer together. Slogans, of course, are usually mendacious, but the enduring emotional power of music, and combined with the novelty of tech branding and the cultural prestige of machine learning, seem to combine to make that easy to forget in the case of Spotify. As a way of reposing the paranoid hypothesis, then, I'll conclude by briefly comparing these two companies, Cambridge Analytica and Spotify. Both rely on unobserved variables or latent factors, and neither one needs to concern itself very much with the question of what those factors mean, if they mean anything at all. It's enough that these factors seem to work in some way. And I'll just pause for a moment and say that a lot of times, there's the defense for Spotify that, okay, maybe they haven't discovered anything real about music affection in these latent variables, but it seems they must have discovered something because it seems to work, right? Well, the truth is, I think that defense isn't really fair because Spotify isn't financially viable. So, the mere existence of Spotify as a company that is still with us doesn't prove that those latent factors do anything meaningful, especially because Spotify has been hemorrhaging money every year in its existence since its founding in 2008. Both rely on extensive user surveillance. In the case of recommender systems, that is euphemized as implicit feedback. Both have integrated with Facebook in ways that are morally and in terms of privacy quite objectionable to many users. And if you haven't followed this story, here's the New York Times breaking a story in December 2018, revealing that although Spotify had denied this, it turns out to be true that yes, Spotify in its integration with Facebook did have access to users' private messages and other delicate personal data in there when they first joined Facebook and integrated the two services. Both Cambridge Analytica and Spotify influence behavior. In the case of Cambridge Analytica, of course, it's voting behavior in general. In the case of Spotify, it's user engagement behavior. It's how long you remain engaged with the service. And both of them are there ultimately to make money. This seems like an obvious point, perhaps, but I think it's one still worth making. Ultimately, the most compelling version of the paranoid hypothesis may simply be that Spotify, like so many other tech platforms, offers an addictive product without any coherent way of demonstrating success or any critical attention to its scientific underpinnings. It logs lots of data about us and integrates with other similar platforms, all in the name of scaling an operation that will hopefully, one day, become profitable. These facts are easy to miss in the entrepreneurial haze surrounding machine learning, to borrow a phrase from Hubert Dreyfus, an early critic of artificial intelligence. Dreyfus was writing in the early days when chess playing, like decent chess playing and simple natural language processing tasks were impressive enough to convince many that an automated form of general reasoning was within reach. Musical meaning is, perhaps, a different kind of problem, one that first-wave AI researchers probably wouldn't have even recognized as a legitimate application of AI. But in both cases, in the 1970s euphoria around AI, and in today's strikingly similar vogue for machine learning, it's important to make the distinction between a product and an insight. It's possible that Spotify has some of both, but it will never be in its interests to help us make the distinction. Thank you.